Hello class and welcome to lesson 3.8 combinations. So today we're going to learn the difference between a permutation and a combination, and it all has to do with the order, if order is important. We'll come back to that, but right now let's just do a couple warm-ups to see how we're doing with permutations. Okay, so number one, how many arrangements of the letters mummy are there? It says to start with the formula. So first of all, you should notice that it doesn't matter what order the arrangement is. And how many letters do we have? So we have 5 letters, so n equals 5, and that's your letters. Okay, number of letters. Okay. And the formula, well, you have to look, do we have any repeating letters? Yes, we do. So we have to use the permutation formula with repeats. So it should be on your formula sheet. Double check to see if it is. Okay, it should be something like this, dot, 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 and that means the total number in our sample space factorial divided by any of the repeats. Okay, so let's use that formula to help us figure the number of arrangements, or number of ways is a short form of doing that. So number of ways, instead of saying arrangements, it's much shorter, equals, well, n is 5, so we have 5 factorial over any repeats? Well, take a look at the m. The m appears 3 times, so we put 3 factorial because it repeated 3 times. Okay, you can just plug that in your calculator as is, but if you want to remember the shortcut on how to do this, 5 factorial is 5 times 4 times 3 times 2 times 1. If I expand the bottom, it's 3 times 2 times 1. And notice that the 3 times 2 times 1 you can cancel, so you're just looking at 20. So if you didn't have a calculator, you could have solved this without the calculator, or just plug it in, folks, and it is 20. So just remember, folks, that this formula is a permutation, P-E-R-M, we're just going to use that for permutation, with like terms or repeats. Okay, so we're going to put like terms. And if you like the word repeats, you can just put down repeats. It's up to you. Awesome. Okay, let's take a look at example 2 here. How many ways are there to select a president, a secretary, and a treasurer for a club or from a club of 5 members? Well, first of all, we know n equals 5. Does it talk about any repeats in here? No, it doesn't. So we got to look for a different formula. So the formula we should take a look here is on your permutations. It should be this formula right here. And if I write it out, it should be n factorial over n minus r factorial. And just so you know, this is a permutation with no repeats or no like terms. I just want to make sure you have this down pat before we add another one into the mix. Okay, so let's take a look. So number of ways, okay, equals, again, it's 5 total, and then you have permutation, and there's 3 because we want 3 different people. 1, 2, 3. Okay. So we're selecting 3 out of the 5, equals 5 factorial over 2 factorial, which remember, that is really 5 minus 3, if you're wondering where that 2 comes from. Okay? Plug it in your calculator or do the short form, and you're going to get 60. For your test, you could just, ladies and gentlemen, plug that in using your permutation button. I have no problem with that. Okay? If it asks you to simplify it or show how it simplifies or show how it would reduce, then you would probably want to show me the shortcut like I did up here in A. Okay? But normally we're just looking for the answer. I'm not too worried about that. Okay. Last question. Okay. How many committees of 3 people are there from a club of 5? Oh boy. How do we do that? Okay. Well, we got to take a look. It says how many committees of 3 people, okay, so that means 3 members are there in the club of 5. So what do we know? This is a little tricky, but we can figure this out. So number of ways equals the number of total people is going to be 5, and I'm going to perm 3 of them, okay, but I got to divide it by how many different members there are. They're repeats, so that's going to be a 3 factorial. Okay, so before I do any further, just remember that 5 is the total, So total, or number of objects, if you want to take a look at that. 3 is we need to pick that. Okay? And 3 factorial is the 3 member groups. Okay? It's the 3 members that we need. Okay? Okay, so how many 3 member groups are there? So plug that in your calculator, folks. You can simplify it to 60 over 6, or just plug it in and you'll get the answer of 10. So what does that mean? There are 10 ways to take a group of 5 and make 3 people the president, secretary, and treasurer. Awesome. Okay, so what's a little different there, ladies and gentlemen, is that we had to consider some order. And that's what we're going to talk about coming up with these next examples. Okay, so for the next page, please do not copy it out. It just says read, do not copy. Okay? All right. So a school glee club consists of the following 5 people: Tom, Henry, Lisa, Brenda, and Adam. In how many ways can a president, secretary, and a treasurer be chosen from these 5 people? Well, we take a look, and it's going to be 5 permutation 3. Okay, which is 5 times 4 times 3, which gives you 60 ways. Okay, and it says, note there, these 60 ways are listed as below, so you can take a look at them, etc. Okay, we also note that when we take a look, we could take a look, is this the president and then the secretary and then the treasurer? Okay, so order is specific. So what we need to take a look at here is realizing that in some cases order is important. Okay. Okay. So if order was not important, if it didn't matter what order, who was picked for the president, who was picked for the secretary, and who was picked for the treasurer, then there would just be the 10 ways, which is just like what we did on the front page, right? We got 10 for an answer. There's 10 ways to do that. But if we need specifically to know who's going where, then it's 60. So what we need to remember is that in some cases order is important, and in some cases it isn't. Okay? So the relationship between these 2 questions is of extreme importance and will be returned to many, many times. Okay? So what we have to just remember is that order is important. If we need to know specifically who's the president, who's the treasurer, who's the secretary, then we got to do a different type of calculation than if we just asked how many ways can we get a grouping of 3. Okay? So this leads us into combinations. Okay? So combinations, folks, is used, and just please put down here that with combinations, this is where order is not important. Okay? So combinations is that we're solving troubles today, and order is not important. Okay? Whereas permutations are arrangements that are important. We're going to do a big box on that next page, so don't worry about that. Okay, so here we go. In general, if we have n objects and we'd like to select r of them and order is not important, we would write down, I'm sorry, I lost my page. Give me 1 second here. Okay, so n PR divided by r factorial. Okay, all right. Okay, so if we take a look at that, ladies and gentlemen, I'm just doing this to develop the formula from permutation to combination. Okay, so please just understand this is just a process. So that the first part becomes n factorial over n minus r factorial, but we still have to divide that whole thing by r factorial. Okay. Now I'm simplifying to get the new formula, so it's going to be n factorial over n minus r factorial, and then I'm going to change the divide by, invert and multiply, right? So it's going to be 1 over r factorial. Okay, and then my last step is to multiply it together, so it's going to be n factorial over n minus r factorial, Okay. And that, in essence, is what we used on the first page just to try to figure things out. Okay? So now we're going to take a look here at this box. Please write this in. A combination is a selection from a group of items without regard to order. Okay? And when we do this, we say N choose R. So I'm going to write this in. We say N choose R. Okay? All right. So this is where you're going to press a different button on your calculator. So it's right near the ones that we're using for permutations, but combinations is a little different. So if we take a look at the last problem, folks, okay, and we weren't worried about the order. We had 5 people, and how many did we want to choose? A group of 3. So plug that in your calculator, 5, choose 3, using that button, and hopefully you'll get 10. That's a simpler way, ladies and gentlemen, of having to use this whole formula. And you'll see it 2 or 3 different ways, okay? So combinations, this one is the one in most calculators that it looks like. I believe if you use the graphing calculator, you have to put it in this form. I think when you look online, you're going to see this, but it all means the same. As long as you know which one to choose, you know how to use which one works for you, then that's fine, okay? So you're just going to see them in different formats, but just remember that the N always comes first and the R always comes last. And just remember that the N is your total number. So N is your total number of items, and R is the ones that you're taking or selecting, okay? Or in this case, we're choosing. All right? Cool. All right, so on the next page here, gang, we want to definitely put this box around. Make sure you know this, because your unit test, folks, depending on the word problem I give you, you need to take a look. Is order important? If it is, you're going to choose one method to answer it. If it's not important, you're going to choose another. So just remember, permutations, which we've already taken a look at, is where order is important, okay? Combinations is where order is not important, and that relates to the Pascal's triangle, okay? So remember when we asked about picking up coffee, you know, you had one person going to pick the first day, another person going to pick another. Order was important, okay? So here, let's take a look here. This example, how many ways are there to select a committee of 4 from 7 volunteers? So we have a total of 7 people, okay? And how many do we want to select or choose from? We want to choose 4, okay? So plug in your calculator, go 7, choose 4. You can plug it in and get the answer just like that, or I'm going to simplify that for you using the formula, which is 7 factorial over 7 minus 4 factorial times 4 factorial, which is the formula we just did on the first page. Okay, just showing you how it simplifies. So 7 factorial over 3 factorial, 4 factorial. And then if you want to cancel out, 7 times 6 times 5 times 4 factorial, all divided by 3 times 2 times 1 times 4 factorial. What's going to happen to those 2 4 factorials? They're going to cancel out, okay? And you should have an answer of 35, okay? All right? Cool. Let's practice with your calculator and make sure that you can answer these, and then we're going to use Pascal's triangle. Okay. So, get your calculators out, folks. I'm going to show you different forms, but we're also going to find out how to plug them in your calculator. So this one should be easy. Just use 8, choose 3, and you should get 56. So if I have a group of 8 people and I just need to pick 3 of them, doesn't matter what order, I'm going to get 56. Okay? Here's another funny thing. If I take that same 8 and I want just a group of 5, guess what? Those are the people left over from the other one. Plugged in your calculator. What do you notice? They're the same. So it's the people who are left over. They become the same amount of groups, right? Pretty cool, eh? Now, this one's kind of funny. This one's written down ways, but it's 7, combination 7, or 7, choose 7. But guess what? If there's 7 people in a group and you need all 7 of them, guess what? There's only one way to choose them. You choose them all. Okay? And the last one, if I have a group of 7 and I'm going to choose nobody, guess what? There's only one way to do that, and that's by choosing nobody. None of you are included in the group, which isn't very nice, but you know. All right. So here's our answers, folks. We've got 56, 56, 1, and 1. Now what I want you to do is look for those numbers in your Pascal's triangle. So let's relate this now to Pascal's triangle. Okay, so pull it out. I know you spent a lot of time writing one, or you've copied one off the internet if you're like me and your writing's too messy. Okay, so look, where do you see, under Pascal's triangle, where do you see 56? Remember how to properly identify it. So what term number is that? Okay, that was term 8 and number, row 8 and number 3. So if you forget that already, this is your row and this is your number. Okay, look how it relates. Isn't that cool, guys? That's exactly what we started with. 8 people total, and we selected 3. Okay, here's another one. Taking a look at this. Where else do we see 56? We see it at T8, 5. So row 8 and number 5, because we're selecting 5 of them. Okay, cool thing you should know the next one. You're looking at Pascal's triangle, that's T. Hopefully you got the 7th row and the 7th number. Okay, and the last one, T, 7th row and the 0th number. Like you start with 0, right? So it's the first, even though we call it number 0. Okay, should be there. Cool. So ladies and gentlemen, a little later after I'm done, I have one more example to do. Hope I don't gross you guys out with One Direction. But here is a video to watch after we do the rest of the lesson, okay? Okay, so Mr. Baker made this up, ladies and gentlemen, and I'm not too much of a One Direction fan, but maybe you are, and I'm not sure if Mr. Baker is or is not. She just did this for an example, so I thought I'd use it. All right, pretend you just go to any concert. Doesn't really matter if it's Nick Jonas or whatever. Okay, so here we go. Last example. So if we go to a concert, okay, and if we buy 5 posters, 3 buttons, and 4 t-shirts, okay, how many different choices did Nick have overall? Okay, so let's take a look at this. So it doesn't really matter which shirt he bought first, what shirt he bought second, third, or fourth. It just says he bought 4 t-shirts. Okay, so what are we worried about? Well, it says how many choices did Nick have overall. That means we've got to include them all. So we start with the posters. And because it's overall, we have to say, and, sorry, give me a second to drop that. And the next one is the buttons. Okay, and the t-shirts. Perfect. Okay, so now we've got our titles in. Let's see what we've got. So, posters. How many do we have to choose from? Well, we got 14 different styles. So it's going to be 14. And how many are we going to choose? How many posters did he buy? 5. So 14, choose 5. And means to do what? And means to times. Okay. Buttons. Let's do buttons. Okay. So there's 12 total. So it's going to be 12. And how many is going to choose? He's going to choose 3 of them. Okay. And means to multiply. The last one is t-shirts. How many are there total? 5. And he's going to choose how many of them? He's choosing 4. Okay. Let's plug some of these in our calculator. Okay. So 14 choose 5. It's going to be 2002 times 12 choose 3 is there's 220 ways for that, times 5 choose 4, which is 5 ways. Okay, and multiply them all together, and you get 202,200 ways. Okay, throw a quick therefore in. So therefore, Nick had 202,200 ways to select, because order wasn't important. All right, so folks, after I send the homework, don't forget to go back and do that video. So page 279, number 1 and 2, just the odd questions, which is like A, C, E, etc. 4, 9, and 11. So the odds are just for A, 1 and 2. So For 1 and 2, do A, C, E, etc. Okay? Hey folks, have a great day. Hope you enjoyed that. That's a lot of fun. Check the video out, folks, and if you need me, come and see me for help. Thanks. Bye-bye.